सारे घर डूबे हुए हैं, सारे फसल बर्बाद है।
कोई सरकार की तरफ से कोई हेल्प नहीं है।
बिहार सरकार ने भी जो है वो अलर्ट जारी किया हुआ है कि नेपाल की तरफ से और भी पानी का डिस्चार्ज हो सकता है।
One of the worst affected areas is the eastern state of Bihar.
It's thought to be the worst monsoon season in decades, with tens of thousands of people forced from their homes in India.
And northeast India is totally cut off from the rest of the country by rail due to floods in Bihar.
Floods and landslides in northern India.
सरकारों के पास बाढ़ के कारणों की जानकारी है, रिपोर्ट है, कुछ नया नहीं जानना, फिर भी इस समस्या को निपटने के लिए कुछ हुआ नहीं।
हम आजादी के 69 वर्षों के बाद भी बाढ़ से निपटने के लिए कोई कारगर नीति नहीं बना पाए। बाढ़ आने के बाद हमारे नेता हवाई सर्वेक्षण करते हैं और सिस्टम बाढ़ पीड़ितों के बीच मुआवजा बांटकर रस्म अदायगी कर देता है, और फिर अगले साल बाढ़ आने तक हमारी सरकारें और सिस्टम गहरी नींद में सो जाते हैं।
When a river flows, it has a certain capacity for flow, and because that is defined by the width and the depth of the river, the cross-sectional area. And when you have a bank full discharge, that means the river is flowing, the flow volume is up to the maximum capacity. And when you go excess of the bank full discharge, then there will be overtopping and the water will spread out to the neighboring areas, depending upon what the slope relationship is between the neighboring area and the bank. This overtopping ultimately results in an area of inundation, which is the normal type of flood. But there are other types of floods also. And these floods could be because of the result of the breach of natural banks in a river, particularly where you have erodible sandy banks. It's easy to erode the bank, and then the river floods into its floodplain. Or in many cases because of the failure of embankments. And where the natural breaching takes place and there is a sudden evacuation of the water into the landscape or into an earlier channel, into an earlier abandoned channel, then it is called an avulsion. So that becomes an avulsive type of flooding. These days there are other things that have happened, because there are a lot of urban areas like Chennai, Mumbai, Delhi, NCR, where we have a very large amount of built up area. And because of a very large amount of built up area, we have a lot of concrete jungle now, and in these areas essentially the phenomenon of urban flooding is taking place whenever there is a high magnitude precipitation taking place or extreme events taking place like the Bombay rainfall and so on. Then there is no place for the water to go into the ground actually, right? And therefore most of it flows as what is known as Hottonian overland flow actually. And this Hottonian overland flow then causes the phenomena of urban flooding actually, which is largely related to overland flow.
India is home to some of the world's largest rivers and most powerful rivers, the Ganga and Brahmaputra particularly, and these rivers produce enormous areas of flooding.
Now these areas have been living with floods traditionally for many years. The havocs were there, but the casualty was less because population was less. At the same time, the people started increasing in number. Then they tended to go towards the flood-prone areas, and they settled there. And now they are affected on a regular basis.
Most of the floods in India are a consequence of the monsoon, obviously. And the particularly severe floods tend to be a consequence of tropical cyclones that come in from the Bay of Bengal, go up the Gangetic Plain, and become low pressure systems that drop an awful lot of rain. That occurs on the plains and, importantly, in the Himalayas.
The floods in the foothills of the Himalayas are characterized by very high sediment input from the mountains. So because they have a very high sediment input, you have to understand the way in which the sediment displaces the river water when it enters into the plains, and therefore can cause channels to spill over into the neighbouring floodplains.
In the Brahmaputra, in the Assam Valley, you also get the same phenomenon. But there, the shape of the valley is very interesting because these cyclones actually get funneled up into Upper Assam, and they drop a huge amount of rain. In fact, the rainfall in Upper Assam may be as high as in Cherrapunji, in other words, about 12 metres a year.
during the summer, during the June, July, August, September time essentially. In the monsoons you get this very high precipitation. And the second problem really there is that there is a lot of sand flux, and in a lot of the cases the erodibility of the bank is very high. You have sandy non-cohesive materials there essentially. And because you have sandy non-cohesive materials, there is erodibility of the banks, and you have excess flow volume because of the very high precipitation. And that together with the bank erodibility causes floods in Assam more or less on a regular basis.
In the drier parts of India, in Rajasthan, for example, the same process occurred in 1990, I think it was. The Luni River flooded and did a lot of damage, and that was a consequence of one of these low pressure systems. Some of them come in from the Arabian Sea as well.
In Rajasthan, the biomass is low actually, right? And if you have a heavily vegetated area, then the flow gets impeded. There is flow impedance. Whereas where you have little or no biomass, the flow is not impeded actually, right? And because of the low impedance in such areas, you have a high amount of overland flow, which is fed into the channels, and then you have this short-lived floods.
Then you think about another dry region, Trans-Himalaya, Ladakh particularly. And there, again, most of the floods are a consequence of the monsoon getting over the mountains and depositing. Not a huge amount of rainfall, interestingly, but very intense rainfall. And there's another set of processes in the Himalaya have to do with glacial lakes that burst and produce floods downstream. Also, landslides, when they fall into a river, they will dam the river, and then that causes a lake, and that bursts. And so you get amplification, you get an increase in the flood effect as a consequence of these natural dams. So, and in southern India, it's mainly tropical cyclones plus just the general monsoon rainfall that generates these floods.
When we talk in terms of places like Mumbai, etc., there the phenomena is what I refer to as urban flooding, because we have actually reduced the infiltration capacity of the water to go into beneath the ground. So underground water flow becomes restricted, and so most of it becomes overland flow. Bihar, North Bihar, much of the area lies on what is known as a fan actually, and a fan is a radial structure which is an upward convex form actually, and it has a lot of abandoned paleochannels where there has been a very high degree of avulsion which has been taking place. And this avulsion has been documented in about 200 years of time. You have had about 10 avulsive channels there actually, right, which have migrated over or have avulsed over a width of about 120 or 150 kilometers, something of that kind actually, right? So North Bihar is largely because of floods related to avulsion actually.
So in the Bagmati River, we have again seen that when we cause or when we use the word flooding, it is not same everywhere. Whenever flooding occurs, there are only some pockets which are more affected by flooding, and that again shows that there is a control of local topography, local geology, or local controls are there. And so that way we have tried to analyze that what are those major controls there. And of course the high amount of sediment supply is coming. There is a huge amount of water which used to flow during monsoon and during monsoon condition. But we have also seen that there are some subsurface fault. One of those faults were also responsible for the 1934 earthquake. It means that those faults were active. And the morphological data shows that these rivers are also responding to those things. So whenever a river will be upstream of any uplift axis, then the channel will get slower and the sediment silting will be more at that point. So that was the local condition there. Second thing, we have seen that the tributary contribution is also important. So it has two major tributaries are there, Lal Bakia and Lakhandei. Both has around the same area, but one tributary confluence is affected by flooding, another is not. That is a typical drainage pattern in that particular tributary. So there is the natural organization of some of the tributaries which are responsible. Third thing is again related with this new tectonic movement is the downstream part, where this block is isn't going downward subsidence is occurring, and because of the subsidence there is a lots of water logging problem is there. So their main problem is not flooding, but water remains there 4 to 6 months. That's a more water logging problem. but it looks like same that during the monsoon condition the flooding will be more, and during rain period it's less. It is still called the flooding. The causes and that time is different.
It's not only the river actually, because even within the landscape we are making roads, railways, and these are all high, generally at a much higher level essentially, and they cut off the connectivity at the landscape scale actually. And because we cut off the connectivity at the landscape scale, then we create drainage congestion and waterlogging in many small areas, right? So what was previously connected with the river stands disconnected now essentially because of the structures. It's not only what we create, what the engineering structures that are created within the river, but also in the landscape essentially, particularly roads and railway tracks. We are actually reducing the organic detritus that comes in the river, and we are creating more and more sediment detritus, silicate, basically silicated carbonate rocks which are there in the Himalaya. Metamorphic rocks, igneous rocks, with the weathering of that regolith is actually being transported.
We have seen that in the river system, which are bringing huge amount of sediment load, a small barrier may cause a huge amount of changes in terms of the sedimentation process. So at the upstream of all these barriers, there was silting problem was there, and then flooding problem was severe. When we also correlated with the overall flooding distribution on the Kosi River mega fan surface, that again shows that wherever these intersection points were more, then the impact of flooding and waterlogging was more in the system. So these kind of human impact has further enhanced those problems.
If you look at the density of roads that was there in Bihar in, let us say, in the 50s or in the 80s, and if you look at the density of road network today, it's much higher actually.
Earthquakes generate a lot of sediment. So if you look at any of the big earthquakes that have happened recently, like the Nepal 2015 Gorkha earthquake, lots of landslides were generated, and that's what caused much of the initial devastation to communities in the valleys that were affected. As the years go by, what we think is happening, or what is happening, is that sediment is being then carried down the rivers. And so the rivers are then getting choked and filled with sediment, which spills into the neighbouring floodplains and causes flooding. And if that sediment found its way all the way down to the mountain front, so in the Wenchuan earthquake in China in 2005, I think it was, that caused huge amounts of sediment to come onto the plains, and it caused all the rivers to choke by about 10 metres of sediment in the rivers, and the water was then dispersed over the plains and caused flooding. So it's the earthquakes generating the landslides, which fills the rivers with sediment, which causes the displacement of water.
During the flood, the river swells, it rises up, and then it induces recharge into groundwater system. Now the farmers or the community which live on the banks, they often have cavity tubes where there is no slots at the bottom. And many times the tubewell is not designed so that its angular space is open. Now what happens, this flood water, it reaches subsurface and travels at a slightly faster velocity. When it travels at a faster velocity, it dissolves mud into it and gets collected in the cavity, and then that mud is pumped out. That is one thing. Second, your angular space between the hand pump or the tube well and the ground is often open, so it enters directly. Now when the first flood is moving, it carries a lot of nutrients, that is human excreta, animal excreta, and other things which are mixed with it. Now they also enter the tube well or the hand pump from sides, and thus you have a muddy water and at times polluted water, where these contaminants cross the desirable limit, and this creates a drinking water issue there. This is the process involved. This is a faulty design, it's a cavity well, and many a times not a tube well or a hand pump which is properly sealed or from sides covered.
But in fact, you could argue that India has been in advance of the world in terms of disaster risk reduction by building embankments. So this has been the key policy, to try to reduce risk before the flood occurs by building embankments along rivers. The problem with embankments is that they often cause more problems than they solve.
It might, kind of help the situation till a point, but beyond a point you are actually messing around with the sediment dynamics, because then you are trying to restrict the movement of the sediment in the lateral connectivity, right? You're destroying the lateral connectivity of the system. And in a lot of these cases, we in the 50s, say for instance in North Bihar, if you take the Kosi, we built 2 embankments around the Kosi, which was, one was the eastern embankment and one was the western embankment, running for on a scale of 100 kilometers plus essentially both these embankments essentially, which meant that we confined the flow of the water, the river, to about 10 kilometers of width. The distance between the eastern and western embankment is about 10 kilometers. So we confined that to within that 10 kilometers, whereas the river used to spread out over 100 kilometers, when it had its natural avulsive habit or behavior actually. So that has also caused a lot of aggradation of the bed actually. Right? And so the channel gradient and the longitudinal to the lateral slopes have also changed. The subject of floods is dealt with the engineers, and mostly the management perspective is given by the irrigation engineers and the hydrological engineers essentially.
Bihar is the best example right now. We have a bund on the side of Bagmati river, which was one of the river which used to inundate a good part of Bihar. And now the flood and irrigation department, they say that look, we have tamed this river, they are not going to flood. But at the same time, if you look at Kosi, which was bounded by bunds for a pretty long time, the river is flowing at a very high elevation compared to the adjacent floodplain. So one breach in the bund is going to bring a havoc.
And that is exactly what happened in August of 2008 when we had a very major breach, and that breach resulted in the displacement of over 3,25,000 people in North Bihar in August 2008. But that was a failure on the part of our failure to maintain it properly. Actually. So embankments is a strategy which needs to be revisited. Maybe I'm not even saying that you can do away with embankments completely. They may be necessary in some places, but if they are necessary, then we need to couple the management of sediment dynamics as well as make sure that our maintenance is at a very high level of footing actually, right, rather than to have poor maintenance actually. So we should be adopting new technology also, and we should be ensuring that we should have repetitive UAVs which are actually running through this thing, detecting any breaches or any tendency towards failure or fracture of the embankments. Of course, the other thing is that you have to also look simultaneously at the sediment dynamics. Floods ultimately cannot be seen purely as something which you manage by way of water discharge. There is also a concurrent sediment discharge actually. Right? And what is happening to the sediment dynamics is extremely important because the bed level rises. And if the bed level rises, obviously the volume that is available in terms of the capacity of the channel reduces actually by that much. And if the precipitation is increasing, the capacity of the channel is reducing, we will make ourselves more prone to flooding actually. So one of the very key things is to be able to manage sediment actually. So it is not just about building embankments, but simultaneously it is very important to see what are the stretches where aggradation is taking place, and the river behavior has to be assessed in terms of sediment dynamics, particularly in terms of the stretches where there is aggradation taking place and the bed is being elevated actually. Right? There we have to take measures to ensure that some kind of operations are put in place where we actually move the sediment out of the channel on a regular basis so that bed degradation doesn't take place.
The way we do it in the UK and the way it's done in many parts of the world are that you use rainfall forecasts from the weather stations, and they produce forecasts which then enable you to predict the rainfall in the next few days and therefore give longer term warnings to communities. At the moment, most of the warning systems from the Himalaya are based on the rainfall happens and people telephone down from the upper mountains and say we've had a lot of rain or the river is at very high level, therefore warn people downstream, and therefore the warning systems are are much shorter, so communities have less time to adapt and be prepared for a flood. And that, I think, is the main difference, and it's one of the things we're trying to introduce earlier warning systems on a day or 2 day forecast basis to regions in the Himalaya.
So in order to mitigate this, first we will talk of in situ mitigation, that is there at the site, at the level of individuals and at the level of institutions. Then to a rescue shelter where they are evacuated ultimately during peak floods, because then they won't be using those hand pumps or tube wells. So at the level of individuals, see, they are marginal farmers, they can't afford money. So there, for them, what you have to do is just ask them, okay, go, make a shallow tube well, but put a proper slot, maybe fine mesh at the bottom, maybe plastic mesh, so that they will have a filtered water. But that doesn't solve the problem of pollutants or the contaminants. For that, you can ask them to chlorinate at least minimum. If they can afford, they can go for a deeper water at the level of individuals. Institutions can go for, like government institutions or state government machineries. What they can do, they can make such deep tube wells which are properly designed with proper slots, proper grouting, everything, and tested for potable quality for all parameters at level of tolas and muhallas, not at level of village. You cannot do that. For every 10, 20 houses, 10, 15 houses, you should have one such tube well. But hang on, this is not the issue, because the moment a high flood comes, all this community is evacuated to a different place. And you have to have this facility there also. First, in true disaster mitigation perspective, such highlands have to be identified. In an ancient time, we used to have citadels. Something similar, high grounds have to be established and confirmed as shelters during peak flood. There also, you don't have now individual houses there. The community is living together. So there are institutions like state government or central government, they have to go for properly designed and screened deep tube wells with grouting from the sides. And then the water quality tested for drinking purposes. This will solve one problem there. But at the same time, the groundwater or drinking water issue or surface and groundwater interaction is a complex phenomenon. And look, you have made a properly designed everything, but you don't have a place for defecation. Then that's going to defeat the purpose. So you have to have, temporary toilets and loose there so that they don't go for open defecation. So that goes hand in hand. And the moment we do these two things, I think the rate of outbreak of diarrhea or other waterborne disease will be minimized and it will save lives.
I think we are certainly not doing enough, because there are a few centers in the north essentially which look at rivers from the geosciences perspective. But I think, by doing enough, the first question that would come up to my mind is that, we should by now have at least 3 or 4 river research institutes in the country. And that these river research institutes should be taking care of different rivers. One for the northeastern region, one for the northwestern region, one for the western, the 2 rivers which flow to the west, Narmada, Tapti, and associated drainage systems. And then we need something for our southern rivers essentially, the Mahanadi, the Krishna, Godavari, and the Kaveri, the Pennar, and so on actually, right? So I think we should be having at least 4 such institutions which are actually looking at the problems of all of these rivers, because these problems are not the same. For instance, the rivers in the north are largely having a meltwater component actually from the glacier. So there is a coupling between the glaciers and the river, whereas the peninsular rivers and the western flowing rivers have no such coupling essentially. One set of rivers which flows from the west to the east is about uplift, which is the Deccan Plateau uplift essentially, right? And then you have the eastward tilt, and that is why they all flow towards the east. So there is a tectonic regime which is very different. Whereas the 2 westerly flowing rivers are because of the rifting essentially, right? So I think the fundamental landscape and the governing issues in these systems are different. So I think there should be strong groups who are looking at the evolutionary perspective. There should be groups who are looking at the resource aspect of it. There should be people who should be looking at the hazard aspect of it. There should be people who should be looking at the river engineering and irrigation aspect of it. So there should be these multidisciplinary institutes where you can have different groups, maybe 6, 7, 8 groups within one institute, who are actually kind of combining their knowledge and learning to respect the knowledge that one group has, and then try and bring about a convergence of this knowledge for effective management of the river systems.
But one of the things that is critically important that India used to do very well, but doesn't do it particularly well now, is to actually give responsibility to the village level. So the Panchayat system should be used for disaster risk reduction. At the moment, what happens is that ideas come from the top and go down to the village level. And so local knowledge, the people living in these areas know the system very well, and their knowledge is being ignored. And I think it's really important for them to play a role, to have responsibility for their own safety to some degree, plus some resources to do it, some training in first aid or whatever is necessary. And simple warning systems at the village level are likely to be very effective by comparison with central warning systems, which often fail because the electricity goes out. So I think that India, it was once said to me in a village in Uttarakhand, people said, the Indian government is too effective. That is, they do too much. We now wait for the Indian government to do things, or for the Uttarakhand government, whatever government, rather than doing things ourselves. And I think that was a particularly important statement. So I think Indian government should try to devolve some responsibility right down to the village level.
What is needed is they would like to know the information about the flooding, when this kind of flooding can happen. Now, our recent work has also shown that the avulsion or the sudden change in channel migration may be predicted, and if it could be predicted, if the proper monitoring will be done, that what kind of channel elevation silting is happening, what kind of connectivity has happened with the main channel and with the channel outside of the sea. If the proper monitoring it could be done, then it could be predicted. If people will know that flood is about to come, then they will be better prepared, and the local people knows that how to live with the flood. So we have to spend more amount of infrastructure, more amount of money towards in this direction, how we can live sustainably with the flood aspect. With that thing, I will also highlight this point that flood also has have some advantages because it brings soil and it is good for the agricultural activities.
Floods in some ways, whether humans are there or were there or not, whether embankments were there or not, in fact floods are a natural part of the hydrological cycle essentially. And floods essentially provide the lateral connectivity between the channel and the areas adjoining the channel. And if there were no floods, there would have been no floodplains. And if there had been no floodplains, we would not have had any agriculture for us to survive actually. So in terms of nutrient dynamics, in terms of soil fertility, it is very important that floods are allowed to occur, right, with the frequency that they are supposed to occur. And irrespective of whether humans are there or not, it is an integral part of the processes of a river to flood. And it is only via flooding that we create floodplains, which are again an essential part of our survival. So floods have a very positive impact actually on the development of floodplains, which is a very critical land area for land use, and therefore dealing with floods is a very complex subject. So if every time an inundation takes place, it is our problem because we have got into the wrong areas. We have started constructing in areas what is the freedom space of the river? There should be zero tolerance for construction. So I think, you see, the trouble is that when you require a solution is generally sought within a very short time frame. You want to do something and bring a solution within a year, 2 years, 3 years. So the engineers generally have had this perception of what is known as a command and control approach. They can command a river, they can control the river, right? Now, as opposed to the command and control approach, we now, in some parts of the world, they have started looking at it as a ecosystems approach, actually, where you treat the river as an ecosystem and you look at the entire benefits that accrue from the river, essentially. So you don't look at it merely as something that you can command and control. It has a certain dynamics. You require to look at an integrated approach where you look at the river from its behavior and its evolution. And that you put the behavioral aspect and the evolutionary aspect into the engineering solutions. Because ultimately we cannot do without engineering solutions. So engineering solutions are there to stay with us. There is a certain language of communication which is required between the engineers and the river scientists. that needs to be put into place, and the river should be treated as something which is both water and sediment, and should not be looked as essentially as a disaggregated sediment water resource for the benefit of humanity.
I think the engineers are slowly changing their habits and thoughts, but they need to do it faster. We need many disciplines to look at the effectiveness of these policies. So, for example, the earth sciences, the rivers, the earth sciences understands rivers in a way which engineers tend not to be quite frank. Engineers view rivers as canals which you can control. Earth scientists think of rivers as rather organic creatures, if you like. It's difficult. You live with them to some degree. But we also need economists. We need people to evaluate the benefit and costs of, say, embankment policies or any other policies. So to make a public policy effective, it has to meet a number of criteria, one of which is benefit, economic benefit, social benefit, environmental benefit. And so we don't see much evaluation of these policies at the moment. It's really, this is what we've been doing for 60 years, we're just going to keep doing it. Let's build another embankment.
The paradigm of development has to have an alternate visions and short and long-term goals. In short-term goal, each village, each flood-prone area, they have to identify safe sites. There are so many remote sensing imageries and other things. With the proper ground survey, they can identify that, look, in this locality, this is a safe site. And then, when they identify it, evacuation is the toughest task, because community is emotionally attached to his house or her house. Now, many a times, if you remember the Odisha cyclone, the disaster mitigation was an excellent example by Odisha government, but they had to force the community. So, such, the disaster authorities, they have to be prepared and force the community, if required, to get evacuated to the new place. And then they live there for some time with all these measures. And after the floods recede, they may be allowed to go back, because they might not have an alternate piece of land to make a house. That's the problem. You cannot provide them alternate piece of land.
A new idea, a relatively new idea, has developed worldwide, which is known as disaster risk reduction. In other words, you try to reduce the risk before the flood occurs, rather than just responding to it. Now, India has had a response system for a number of years, evacuation systems, warnings, relief payments, compensation, etc. So India, while it tries its best to do the recovery phase of a disaster as best it can, and I think the 2013 Kedarnath disaster was a good example of the role of the military, which was quite effective. The problem we've got is the disaster risk reduction strategy is just basically one strategy, which is embankments. And it needs to be diversified, because as climate changes, we need to be flexible about how to deal with floods. And just having one policy, one solution, really doesn't allow for flexibility.
I think there's actually little that can be done to minimize the actual flood event, but we can try and build a resilience to the flood events if we are clever about living with the flood events. The instinct for governments and local bodies is to bring in engineers to try and control the floods with embankments. This is a disaster, and so because what it does is causes the natural tendency of the river system to move. It stops that and blocks the river into one big channel. And so, for example, the Kosi River is now confined by embankments, and the embankments are causing the sediment to build up. So the Kosi River is getting higher and higher and higher in the embankments, and the other side of the embankments it's staying low. So there will be another flood, just like the 2008 flood, at some stage in the future, because that river can't be held between embankments. It will escape. So I think you have to build resilience through understanding how to live with floods, how to manage them, like communities have done for many years. And the danger is we now think we can control floods, and you can't control them. You have to learn how to live with them and prevent yourself from simply trying to engineer them. That's a mistake.
That it is not only the government, but it has to be a people's movement. I mean, government is very critical and central to this, but beyond the government, it also has to be a people's movement, where everyone has to take it upon himself as a citizen of this country that we have to preserve the river, because if there is no river, then we are not there. As far as the people are concerned, I think it is both two ways. We should actually spread awareness right from class 3 or 4, where children begin to develop a certain awareness of their environment, that the river is the single most important entity for our existence and sustenance. And unless the respect for the river is generated in children who are about 7 or 8 years old, and then that respect is nurtured through the entire school phase till class 12, then the citizens, then these children, when they grow up to be responsible citizens, will certainly know how to respect a river. So there is a very strong element of trying to put awareness into the awareness as a important subject, both in terms of outreach as well as in terms of